Okay, we're doing section 10.3, guided notes for part 1, multiplying and simplifying radical expressions. Our objectives today, we're not actually going to do number 1, we're really going to just work on number 2 today, which is use factoring and the product rule to simplify radicals. And let's look at the first thing here, which is our perfect squares. We have all the perfect squares listed for you, and I have these because it's going to make life a lot easier if you know most of these. So the more you can memorize, the better. But they're all listed here so that you can figure it out. And of course, you know that 1 squared means 1. 1 is the perfect squared, and 4 is the perfect square, and 9, everything on the right side of the equal sign are the perfect squares. And if we take the square root of the number on the right side, so let's say the square root of 9, we get the number that's on the left. We get 3. So let's look at the steps for simplifying radicals. First thing is find the perfect square that divides evenly into the radicand. That's the number under the radical symbol. Second is rewrite the radical as 2 radicals multiplied together, one with the perfect square and the other number used to multiply to get the radicand. 3 is take the square root of the perfect square and write it in front of the leftover radical. So let's try it. Example 1. We've got the square root of 12. And so if I'm looking at my list, I got to find a number on the right side of my list that goes into 12 evenly, and actually we want the biggest number on the right side of the list that goes into 12. Now there are more than just these numbers because 6 and 2 go into 12. But 6 or 2 are not on the list up here. So we can't use 6 and 2. But we can use 4. 4 goes into 12 3 times. So, let me move it back up here. We write it as, it says write it as 2 radicals multiplied together. And so we're going to write it as the square root of 4 times the square root of 3, because 4 times 3 makes 12. And then it says take the square root of the perfect square number. I need some more room here. Okay, so we've got the square root of 4 is 2, and write it, and then it's the last thing it says, take the square root of it, and then write it in front of the radical that's left. 2 times the square root of 3, and that is a simplified radical. Let's do 72. Now when you start getting these larger numbers, this list will also help you with this. We're starting getting the larger numbers. The easiest thing to do, because you don't know where to start on the list, the easiest thing to do is take the number and cut it in half. So half of 72 is 36. Let's start right there. If we look at our numbers, we see we got 36 right there in our perfect square set. So 36 is going to go, does 36 go into 72? Yes, because we just divided it by 2 and got 36. So 36 times 2 makes 72. So we're going to write our square root of 72 as the square root of 36 times the square root of 2. And square root of 36, we can take that is 6. Square root of 36 is 6. And we'd write the square root of 2 after it. We cannot take the square root of 2. And the square root of 2 won't break down anymore. Let's look at C. Now we're getting even bigger numbers. 294. Well, 294, if you cut that in half, you take 294 and you divide by 2, you get 147. So we can start our list on our list at anything that's 147 or lower. So if we take 144 and we try 294 and we divide by 144, we get 2.04 and the number goes on forever. And so that doesn't work. So we moved to the next number up the list. We started at 144. Now we're going to try 121. See if 121 goes into 294. 294 divided by 121. It's 2.42. It goes on forever. It doesn't go in evenly, so we move on. I know 100 is not going to go into 294, so I can skip that one. Let's do 81. 294 divided by 81. 3.6, that's a decimal, so it doesn't work, so try 64 then. 294 divided by 64, 4.59, keep going down the list. 294 divided by 49 is 6. We finally found one that goes in evenly. 294 divided by 49 is 6, so that means I can split this up into the square root of 49 times the square root of 6, because 49 times 6 will make 294, and the square root of 49 is 7, so 7 times the square root of 6. Pause here, try the example on the checkpoint on the next page. When you come back, I'll give you the answer. Okay, on checkpoint 1, A is 2 times the square root of 5. B is 6 times the square root of 3. And C is 5 times the square root of 10. Let's throw some variables in there now. Look at example 2. I'll move this up here. We got the square root of 150p. You treat them separate. You do them separate. We're going to do the square root of 150 like we've been doing in the first example. And then we're going to have the square root of the variable part, which is the square root of p. Now we know we can't take the square root. We can take the square root of something squared or something to the squared or bigger. We can't take the square root of p. So what's going to happen is this square root of p is just going to stay underneath the square root with our other number that we have left. So let's just take 150 right now. 150, I know that 25 goes into it. That's probably the biggest one. So, whoops, let me get my pen out. Square root of 25, and it goes in 6 times. So square root of 25 times the square root of 6, and we got a square root of p left over here. So we're going to split this up into 25 times 6 times p. And then we're going to take the square root of whatever we can take the square root of, which in this case is 25. So we got 5 times the square root of 6 times the square root of p. And anything that's under a square root after we take the square root of whatever we can take the square root of in our problem stays under the square root. So we get 5 square root of 6, and we'll make it under 1 square root of 6p. Let's try it with b. 96. 96 can break down into 16 times 6. So we've got the square root of 16 times the square root of 6 and times the square root of x squared. Square root of 16 is 4. We can take the square root of that, so we'll write that as 4. Can't take the square root of 6, so we're going to leave it as the square root of 6. But we can take the square root of x squared. The square root of x squared is just x. So we got 4 times square root of 6 times x, and we can rewrite it, and we always rewrite things without a square root in front. So that makes 4x square root of 6. And that's our answer. Let's look at C. 216 is 36 times 6. So I can write this as the square root of 36 times the square root of 6 and I've got the square root of x cubed next. But I know I can only take the square root of even numbers, and I divide by 2 of even power, sorry. I divide by 2. So I'm going to rewrite this x cubed as x squared times x, because x squared times x is still x cubed, but if I write it like that, then I can take the square root of the x squared, but I still got the square root of x to deal with in my answer. And I got the square root of y, and I don't know if I'm going to fit this, y to the 4th, I guess I did. Now we're going to rewrite it taking the square root of everything. Square root of 36 is 6. I can't take the square root of 6, so I got the square root of 6. I can take the square root of x squared, that's just x, so I got times x. Can't take the square root of just x, so I'll just have another square root of x. And the square root of y to the fourth is y squared. We divide the power by 2. Divide it by the root, and this is square root. So y squared. If I rearrange it so things without a square root are in front, I get 6x y squared and the square root of 6 and x is next. Let's look at D. 96x to the 7th. Well, we already did 96 in B. We already did it in B. We know it's 16 times 6, so we'll do it again. Square root of 16 times the square root of 6. X to the 7th is odd. Any odd power, you're going to write them out as square root of the x to one less than that odd power. So in this case, it'd be square root of x to the 6th to get an even power times the square root of x. So anytime you have an odd power, you end up with the square root of x. And the square root of 16 is 4. Can't do the square root of 6, so we leave it as the square root of 6. The square root of x to the 6th, we're going to divide that power by 2, so that becomes x to the 3rd. And we got another square root of x. Rewrite it with things without the radical in front. 4x cubed. And then things underneath the radical, 6 and x. That's all for 10.3 part 1. I will see you in class.